I want to talk a little bit about why cross-platform is sometimes good, sometimes bad, and why you should maybe do it depending on the needs of your team. More specifically, I want to tell you a little bit about what this talk is not. If you came today to get a concrete answer for whether cross-platform is right for your team, I'm not going to tell you. If you came here to have me stand up on stage and roast React Native for 45 minutes, I'm not going to do that either. Or if you came here for a technical deep dive of the pros and cons of React Native specifically, so that you can go back to your team and tell them why you shouldn't do React Native, I'm also not going to do that. But what I am going to do is walk you through the history of our experience with React Native, introducing it at Airbnb, and then eventually sunsetting it. And also the organizational challenges that we faced, starting with the mobile team, building a cross-platform team, and now going back. So let's dive right in. Let's go back to 2015. Back in 2015, we had two mobile teams. We had Android engineers and iOS engineers. We sat right next to each other, but we had two completely separate code bases. We would talk all the time and we would build the same features, but we ultimately didn't share any code. In 2016, we introduced React Native. For the first time, we had engineers hopping between Android and iOS, and we even introduced a third platform, React, into our code base. This posed a number of unique challenges because we were doing things we had never done before. But in 2018, we've decided to sunset React Native, and we're returning to this world. So going back to 2016 again, let's talk about why we started. We have to go back to March of that year. This is when we introduced React Native into our code base for the first time. This was a pivotal moment for Airbnb. Just a few years prior, mobile was basically an afterthought. It was basically no bookings, no one really used it. We barely even had an app. We started to build a mobile app, and it very quickly became clear that mobile was extremely important for the future of Airbnb. Not only was it an increasingly large share of bookings, but hosts were using it as a critical tool to manage their listings, and guests were using it as their primary device when they traveled. At the same time, we decided to make the company mobile first. So we split up the single mobile team into individual feature teams. But unfortunately, we didn't have enough mobile engineers to do that. We had about 15 Android engineers, 15 iOS engineers, with probably over 100 engineers in the company who knew React and were building our website. This unfortunately left entire teams that were trying to go mobile first and trying to ship code on mobile, but they literally didn't have a single engineer to do so. So what were they supposed to do? Around the same time, Facebook had introduced React Native, which let you properly write React on mobile, and write React code as we had already done on our website, but actually ship it on Android and iOS. There were two engineers in particular, Leland Richardson and Spike Brem, who were really excited about the potential to allow more teams to contribute to mobile, so they decided to do a pilot. They introduced React Native into our code base, and then decided to pick a single feature that was isolated and hadn't yet existed on mobile to see if they could launch a feature with React Native. So they picked reservation alterations. And a few months later, they shipped it. Again, this never existed on mobile before, so it is strictly a win from this perspective. We introduced it to our code base. They built a lot of the core infrastructure necessary to get it off the ground. They had to build our design language, experimentation, internationalization, and many other core infrastructural libraries just to get this first feature running. And in fact, it worked. As you can see behind me, it's actually a fairly complex feature. It has a calendar and a lot of complicated UI, and they were able to properly launch it on React Native a long time ago. It was around this time when Airbnb was about to go into its first major product vertical since the company launched in 2008. In November of that year, we launched Experiences. Experiences allows you to book experiences with hosts in cities around the world, not just places to stay. They faced a lot of the same challenges as other teams at Airbnb. They had to build a lot of stuff, but they literally didn't have enough engineers to do it. There was no way that they were going to be able to launch had they gone native. So they bet the farm on React Native. In November of that year, they launched the entire platform 100% on React Native. This was a huge milestone for React Native at Airbnb, and it sort of solidified its place in the code base. Fast forward through 2017, and we built a lot more. More and more teams adopted React Native. In fact, we launched over 220 unique screens with React Native. It amounted to about 80,000 lines of JavaScript and 40,000 lines of JavaScript infrastructure supporting it. That doesn't even count countless lines of Java, Objective-C, and Swift to bridge all of our native code and make it a seamless experience. And the cross-platform dream that we had hoped to get out of React Native actually panned out pretty well for product engineers. 95% of all of the product files in the entire React Native code base didn't have a single platform split in it. So we did a lot of work on the infrastructure side to make the platform affordances built into all the infrastructure. And we built a lot of the platform affordances into the core design library so that our product engineers didn't have to worry about it. We even built a lot of fairly complex things. We built an entire navigation stack that was built on native libraries like activities, UI navigation controller, and it used native elements like a native Android toolbar and UI navigation bar in iOS, so that as you navigated between a native screen and a React Native screen, they were completely indistinguishable from each other. We even built screens with long lists, parallax, auto-playing videos. But ultimately, all of this work accounted for about 15% of mobile engineering at Airbnb. It was also supported by a minimum of 2 full-time engineers working on the infrastructure for React Native. During 2017, I was one of those 2, but I've since moved back to Android. We also had the support of 6 engineers working on Android infrastructure, iOS infrastructure, as well as build, tooling, and CI pipelines who helped us out. Part of our job was to also work with product teams to give them mentorship and support so that they can learn React Native, not have to dive into native, but we also met with a lot of teams to figure out when it was right to use React Native across the company. We then wanted to get a pulse on how React Native was doing, so we sent everyone a survey. We sent all the engineering managers and engineers who had used React Native a survey to understand where they stood. From the engineering manager's perspective, it turns out that they were relatively split as to whether they thought React Native was allowing them to ship code faster or slower. For some teams, it worked really well, and they were absolutely able to ship code faster and ship things they wouldn't have been able to otherwise. But for other teams, it was challenging, and they encountered roadblocks because of challenges due to React Native, and they actually ended up shipping code slower as a result. Now, you need to take it with a grain of salt, because if they went with React Native, they never actually built the native screen, so they don't really know how to compare it directly, but it's a good proxy, and so you see it's roughly split down the middle. On the other side of things, out of the 19 engineers who responded to the survey, 15 of them actually said that they were having a positive experience with React Native. So the engineers who used it actually really liked it. Of those engineers, about half of them had previous experience in React, but only a third of them had experience on either Android or iOS. And most of them would use React Native again. So once we did the survey, we had to look at what we built, think about our investment, think about how people liked it and what we were getting out of it relative to what we were putting into it, and we did the math. It turned out that it was really complicated. There were a lot of parts to it, there were a lot of factors. Some of them were React Native specific, some were not React Native specific, some were Airbnb specific, and some were not. And if I went through all of them, I wouldn't have time to cover it all today. But at the end of the day, once we balanced this entire equation, we eventually knew we had to sunset it. And again, there are so many parts of this algorithm that there's no way I could cover it all today. So I'm just going to talk about one part, the organizational challenges. So I decided to cover the organizational challenges because they weren't really specific to Airbnb, nor were they specific to React Native, and they'll apply to many, many teams who are considering going cross-platform. So let's dive right in. The first organizational challenge is that React Native and cross-platform frameworks in general are simply really polarizing. There's a long history in the mobile community of cross-platform frameworks shipping subpar experiences. I know most of the people in this room know Android and really care about shipping only the highest quality experiences to our users. Unfortunately, we know from previous experiences in some other frameworks that sometimes this is really hard with cross-platform frameworks, or you think of companies that choose to use them as companies that don't invest as much in native. This means that a lot of times engineers have a lot of predispositions and reasons that they don't even want to consider a cross-platform framework because of the long history that they built up in their mind. You also have to keep in mind that we're all humans. Sometimes we think that we're engineers, so we're super, super rational. We're having a conversation, debating the pros and cons of a cross-platform framework versus native or vice versa. But ultimately, we all kind of have opinions and thoughts of our own. And we saw sometimes that you thought you were having a conversation about the technical pros and cons, but in reality, you were just kind of using them to confirm and back up what you already wanted to believe. In addition, you have to be very careful when you roll out your first few cross-platform experiences. If you have engineers who are very wary of shipping cross-platform experiences and think that it leads to a subpar experience, and you end up shipping a subpar experience, that becomes a very painful thing that you have to overcome in the future. You're already probably going to fight an uphill battle, and it only makes it that much harder. In fact, this happened to us in one experience very early on. The experiences team had to build a new itinerary so that guests could find information about their experience after they booked it. They came to us to ask if they should build it in native or React Native, and we actually suggested that they build it in native because it was a launch screen of the app, and it was also highly complex. However, like I said, they didn't have the resources to actually build it in native, so they went with React Native anyway. It was originally supposed to be a prototype and only for experiences, but it ended up encompassing the entire home's itinerary as well. That's a really complex page that was previously owned by many, many teams and had years of minor details, and there were reasons for a lot of the complexity because it's actually a very complex page. Well, this ended up launching, it got dropped in as a 4,500-line PR 2 days before branch cut, and it had only been tested on iOS. And I know you're probably thinking that this would never happen at your company. But we've all been in the crunch time leading up to a big launch. You're working long hours, and you simply have to get something done, so you often end up doing things that you're not proud of. We ended up launching this itinerary, and it was really broken for a lot of our users. And this became a big scar on the history of React Native at Airbnb that we had to overcome. And I'm honestly not really sure we ever fully overcame that original experience in the eyes of a lot of our engineers. Another challenge is that cross-platform by its name might make you think that you're going from 2 platforms to 1. But in reality, you're going from 2 platforms to 3. There's no way going cross-platform that you're completely going to get rid of native. You still have to ship a native app, and you frequently have to bridge native infrastructure, go back to native views. You might have to wrap something like a video, a map, Lottie, something like that. Or you have to wrap your existing native infrastructure. Now, as you saw from that first slide, those 2 native infrastructure teams might be fairly independent, or they've designed the APIs to be canonical for the platform that they were written for. You then have to figure out how to wrap those APIs into a single surface area that makes sure you accurately and fully capture the functionality of both platforms, and then expose that API to the cross-platform framework in a way that also feels canonical to users of that framework. So while it might, in some cases, it's a simple one-to-one bridge, but in many other cases, you actually have to do a lot of thinking and work to figure out the right way to bridge it on top of actually just doing the work. In addition, if you have a hybrid app, you might think that you're building an isolated screen by itself. But ultimately, you're going to have to share some sort of state with other parts of the app. Whether it's something simple like whether you're logged in and user profile information, but sometimes as product requirements change, you'll find that your screen often very soon has to interact with other parts of the app that might not be written in the same framework. We found this to be the case numerous times. An app had all of its state either on native or React Native. We used Redux. And then you had to go back and forth between the 2 platforms. These are 2 completely different ways of storing state. If you need to share them, you need to do all of the work manually to parcel and unparcel all of the data that you want to go between the 2 frameworks. Not only is there memory overhead, but there's time overhead, and also the engineering overhead to do that. And we often saw engineers cutting corners and sending less information than would be ideal for the best user experience, because it's just a lot of manual work to do it. Another challenge is that these frameworks take a lot of support. It's really easy to just find a library online and use it in your app. Anybody can do it. However, when you're adding a cross-platform framework, you have to remember it's an entire platform that you're introducing to your app. It's not just something that you throw in and forget about. You have to do all the work to bridge that infrastructure, and it's an entire new platform that people have to learn. And once you introduce it to your code base, you'll find that a lot of the teams that adopt it are the teams without as much mobile resources. In fact, in many cases, they had none at all. And so you have times when you have a team that's shipping code on Android and iOS, but they have to go into native, and no one on their team has ever done it at all. So someone in the company has to be there to help them. Otherwise, they're going to be diving into a framework, they're going to be touching code they've never seen, they're going to be working in a language they've never used, in an IDE that they've also never used. So you have to make sure that your organizational incentives are aligned so that there's actually a team that can help them when they need help. You also have to keep in mind that these platforms are new. they're very fast moving, and they're often breaking changes. So in order to keep things up to date, you have to actually put in work, otherwise you just fall further and further behind. In fact, there was one React Native upgrade for us last year that was particularly challenging. Because Facebook ships React Native tied to basically the tip of tree for React, there was a series of React Native releases that used React 16 beta. Now, this by itself wasn't really a problem because React 16 beta was stable enough for them to be using on their website. However, a lot of the libraries that were used in React Native were primarily focused for web. And external websites hadn't switched to React 16 beta because it was a beta, and a lot of libraries have a policy of not supporting beta versions of React. Even though it was stable, that was still a policy, or they just hadn't done the work yet to support it. So we found it really challenging because we couldn't upgrade React Native because none of our third-party libraries that we were using were actually compatible with it. This is just one of many examples we had where we tried to upgrade React Native or we tried to do something, and it actually took a lot of work. And if there wasn't a dedicated team to look into it and actually spend weeks and weeks and weeks to get it up to date, you'd be stuck on a really old version, and it only gets harder and harder to do over time. In addition, once you put it in your app and you build that core infrastructure, your native infrastructure teams are going to keep doing their job. They're going to build a new experimentation platform, they're going to make internationalization better, and your design language is going to keep moving forward. So someone has to be there to continuously bridge all that infrastructure, or again, you're just going to fall further and further behind. And as a developer, testing in React Native or another cross-platform framework can be challenging. And I'm not really talking about unit tests or integration tests. I'm just talking about your day-to-day development. Now, if you work in a larger company, there's a lot of people who are focused on your development environment. They generally move pretty quickly. I know you've all probably come back from PTO or another project only to find that you can't just build the app anymore. Something has changed, there's some script you have to run or something you have to install in order to get things to work correctly. This is certainly true for Android and iOS code bases at Airbnb, but this was even more true for React Native. We were always working and building new things and making things better, but that meant that if you didn't stay up to date, you fell behind. So what we found is that often people would spend they would leave for 2 weeks, and they'd come back, and they'd have to spend days just getting Android and iOS and React Native back up to speed just so they can start working again. This is not that big of an overhead if you're just working on one platform, and you might not really notice it, but if you multiply it by 3, it actually becomes a big problem. In addition, we all probably have MacBook Pros or some other laptop with 16 gigabytes of RAM. We're always complaining about Gradle build times and running out of RAM and everything slowing down. You run a bulk build and Spotify starts stuttering, for example. Now imagine having that, plus the iOS build system, plus your React Native development or other cross-platform frameworks set up, and you have a situation where you literally can't even run everything at the same time. It's simply impossible. So what ends up happening is you end up running just one of them, right? And you usually pick the one that you're more familiar with, which is the one in your pocket. And in the case of most Airbnb engineers, it was an iPhone. This meant that Android was tested a lot less than iOS, and we ended up, people would write some code and assume that it would just work, and they'd find they would maybe smoke test it at the end, only to find out later that it didn't quite work as they expected. You're also adding an entire layer on top of Android and iOS, so that when something goes wrong, it can be really hard to figure out why. We had one situation where randomly on some phones, React Native screens would stop rendering. It was totally random, and it would happen on fast phones like a Pixel, but then not other phones that were fast, and then it would not happen on slow phones. We couldn't figure out any pattern for when it happened, but when it did, all React Native screens just rendered white forever. It turned out that a week earlier, we had removed Fresco initialization from App Startup. React Native is bundled with Fresco, which is an image loading library, but we use Glide. And all of our React Native components use Glide under the hood. So we figured we probably didn't need Fresco because we weren't using it and we had fully removed it from the component tree. But for some reason, when we removed the Fresco initialization, some React Native screens would randomly start rendering white on some phones. So these are and figuring out the link between the two literally took multiple engineers days of work to track it down. We basically had to do a git bisect in order to figure out what was going on. The community is also challenging. It's a young community, it's very fast moving. And I know we all go to Stack Overflow and Google all the time. So when you have a question, you Google it, and you can probably find your answer if it's on Android. If you go to Stack Overflow, there's 1.1 million Stack Overflow tags for Android. There's almost 600,000 for iOS. but there's only 36,000 for React Native and 4,000 for Flutter. Even though these are fast-growing communities, there are times when you have a question and there literally isn't an answer online. And often when you do find the answer, you'll find that it's either out of date, deprecated, or doesn't work in your code base for some reason. The 3-platform challenge also applies to open source libraries. Now, anyone in this room could probably write a really high-quality Android open source library because you know Android really well. But nobody knows all 3 platforms really well. So if you wanted to write a React Native library or other cross-platform library that has native code, you're ultimately going to be writing code in a platform that you're not very familiar with. And unless you have the perfect team of everyone who's super aligned across all 3 platforms, you'll wind up in a situation where you generally have worse support or lower quality code on one platform or the other. Now, this is something we certainly experienced where we'd get a library, it would work on iOS, and then they would smoke test it on Android after it was all built, only to find out that that open source library didn't actually work as well on Android. Another question that we answered over and over and over again is whether a team should go native or React Native. If you're building a hybrid app, this is inevitably going to be a question that comes up over and over again. And over 18 months and having this question thousands of times, there really wasn't an easy answer. In fact, we intentionally did not even make like a canonical document that teams could go to answer the question because it was so complex. It depended on so many factors, from their current resources to future resources to what they're trying to build to who they were going to interact with, that it was a full conversation with every single team that was considering it. And think about it from the perspective of an engineering manager. Engineering managers are often in charge of a full stack team, so they themselves may not have that much mobile experience. They know they have to ship something on mobile, so who do they hire? They know they can build it in Android and iOS or your cross-platform framework. But they need to resource their team, they need to request a certain amount of headcount, and then they need to go and hire the right people. They need to then answer the question of native or React Native with far less context than even anyone in this room might have. It's a really complicated question, and there's really no easy answer to it. And one of the things we hoped we would see on the resourcing side is a lot of crossover from our vast React expertise to mobile. But unfortunately, we actually saw a lot less of this than we'd hoped. We thought that React engineers would just come on over and start working in React Native because it's just React at the end of the day, right? It didn't really happen, though. And there's probably a variety of reasons for this, and I think we could have done better. But engineering managers didn't really adjust headcount or resources to allow the web engineers to work on mobile. But think about it from the perspective of them. They're used to there being a huge overhead to start contributing to mobile. It's this totally different platform. It's generally like a black box or like a dark hole, kind of off in the corner. Mobile is this other world that they know nothing about, and it'll take them 6 months to ramp up on. This is just kind of the way they think about it, similar to the way that some of you have predispositions to cross-platform frameworks in general. So they didn't really even consider it, even though they really could have moved over very quickly. That being said, though, we did see a few examples when they did, and it actually worked really, really well. We had one example where we were working on a new project. We specifically picked one of our favorite and best React engineers in the company. He's truly one of the best in the entire industry, and we wanted to see what he would think of React Native. So we specifically partnered with him. We got him up to speed in React Native in about 3 days. We then had him build this screen with React Native. We supported him a little bit with some of the mobile paradigms and some React Native specific things, but he was ultimately able to build an incredible app in just about a week. It had parallax, it had auto-playing videos that played and paused during scrolling, it even had 60 frames per second animations. It was truly a beautiful screen. It was completely indistinguishable from a native app. He then went and rebuilt the entire feature on web and mobile web in about half the time than it would have taken normally, because everything that he'd already thought of, from React components to the Redux state, carried over perfectly. So this one engineer actually built it on Android, iOS, web, and mobile web in just a fraction of the time it would have taken on Android, iOS, and web with 3 engineers. It was actually really incredible, and I wish we had more of an opportunity to explore this because there's a lot of potential there. But think about it from the perspective of one of you. If you go and build a feature, let's say for the sake of argument that it'll take about a week, okay? It takes a week for you, then it takes a week for an iOS engineer. Now imagine you go and work on this cross-platform framework and it takes you a week and a half. Maybe there's a few things that make it take longer, more testing on 2 platforms, but from your perspective, it actually took longer. 50% longer, that's a big difference, right? But from the sake of the organization, it actually took fewer engineering resources to build the same screen, and you're guaranteed that the code is going to run the same across both platforms. Let's say you have something like logging, analytics, strings, something like that. We have lots of problems where there's subtle differences in the behavior of Android and iOS, such that when data science use the data, they think that they're working with the exact same thing across both platforms, but platform differences in the analytics may actually be to subtle differences in the implementation of the screen. And this is not something that's going to happen with a cross-platform framework because it's only written once. And finally, this is a big one that we didn't really realize until towards the end of our working time with React Native, is that it actually impacts hiring. If you start talking about the fact that you're using cross-platform framework, for whatever reason, people started to assume that you're 100% on that framework. I can't really blame them for it because they don't work for the company, they don't really know what it's like on the inside. We were about 15% React Native, but there were a lot of people in the community who thought we were 100%. And often, native engineers don't want to join a company that's fully cross-platform, whether it's from a predisposition or just because they want to do Android and they're not doing Android, right? Or even if you do choose to go 100% cross-platform, you're still going to need native engineers to work on that core infrastructure and to make sure that the release process for your app is smooth. And it's really hard to hire native engineers if they know that your app is fully cross-platform because they're shoehorned into this tiny little infrastructure role supporting a bunch of cross-platform engineers. You also then have to make sure that you communicate to recruiters to make sure that they're looking for candidates who know the cross-platform framework. And then you need to build an interview pipeline to make sure that you hire the best people to actually bring in talent for that. So taking a step back, did we fail? We launched experiences with React Native, we shipped 220 screens. People who used it generally liked it, and we learned a lot. At times, it really felt like we were actually working in the future. You'd write a line of code, you'd hit save, and it would show up on Android and iOS in just a second. This hot module reloading in React Native actually scaled up to the size of Airbnb, and it continued to work at our scale. We were even working on things like code push. Code push was going to allow us to deliver over-the-air updates to our React Native app on the fly. This was going to allow us to do things like fix crashes and fix bad experiences for users without having to deploy a new app. We even had grand plans to get to a place where we'll have continuous deployment for our React Native screens. This is a complete game changer. You can move so fast, you can learn from your users faster, ship better experiences, and it changes the way we think about everything. But unfortunately, some of the challenges made it more difficult, and it never really grew to be more than about 15% of our mobile engineering. So even though we're sunsetting it, I really don't think we failed. And in addition, we spent a lot of time with React Native, and we think it did some things really well. We think that the reactive model of React Native is actually really effective. There's a reason that React has become so popular on web. It's really good for small projects, but it also scales up to the largest websites like Facebook. Which is why we wanted to take some of our learnings from React Native and reinvest them back in mobile. So I want to talk about one more thing. I want to talk about a new framework that we're working on called Mavericks. Mavericks is an Android architecture library that we started building to make it easier and faster to build products at Airbnb on Android. It wasn't designed to be this academically pure, super complex library that's testable from day one and everything. We just saw that people were doing the same things over and over again. They were doing things with the Android lifecycle, save instance state, process restoration, and then ultimately, most of our screens, if you actually think about it, it's a toolbar and a list of components, there's maybe a footer, but it's actually remarkable how many screens fit that pattern once you take a step back and look at it. So I want to talk a little bit about it. And I know what you're probably thinking. You came here to learn about cross-platform frameworks, and now we're just talking about another MVC, MVVM framework for Android. And I'm here to tell you that we are. I actually, a while back, I thought to myself that I would never do one of these talks. I really, there's a lot of them out there. There's a lot of really, really smart people, and you can go online. You can probably find 1,000 MVVM, MVC talks on Android, on YouTube, or even at this conference. But I want to share this one because I'm really, really excited about it. I've been doing Android for about 6 years, and this is honestly one of the most exciting projects I've ever worked on. In fact, don't just take my word for it. We did a pilot with about 14 engineers at Airbnb. We then sent them a survey asking them to rate their overall experience 1 to 10. 13 of them gave it an 8 or higher. This has been extremely effective for the engineers at Airbnb to allow them to focus on building the product. During the pilot, we built about 50 screens. Keep in mind, we had about 220 after 18 months of React Native. So this is what it looked like during the pilot. We worked with a few teams. They adopted it very quickly. It became the default for them. But then we opened it up to the rest of Airbnb. And it looked like this. We just crossed 120 unique screens built in Mavericks. And we just started working on it in like April. So enough graphs and stuff. Let's look at some code. In fact, let's build this screen. It's really, really simple. I made a simple screen just because the code fits on a slide, but I assure you it scales up to very complex screens as well. This is the Hello World screen built with Kotlin and Mavericks, but don't read too much into it because I don't really like doing it this way. Mavericks pairs really, really well with a library that we open sourced about 2 years ago called Epoxy. Epoxy is a library that makes it really easy to build heterogeneous recycler views using components. So the same screen built with Epoxy looks more like this. This is it. That's all the code required to render the screen on the right. Let's break it down. We're going to start with a fragment. Now, I know that a lot of you guys don't use fragments anymore. We do at Airbnb, and honestly, they've been pretty effective. For the most part, they just work. We've had times over the years where they've maybe caused crashes here and there, but over time, not only have they gotten more stable, but we've learned how to use them and leverage them pretty effectively. So more or less, honestly, they work pretty well for us. And now with Mavericks, we have no problems at all with fragments, believe it or not. I mean, maybe a little bit with backstack and whatnot, but for the most part, fragments work really, really well. So we've continued to work with them. Google's also reinvesting them and building a lot of infrastructure on top of fragments. So we want to make sure that we're staying close to the Google recommended architecture so that we can leverage all the work that they're doing. So here we have a base fragment. It has a default layout. Like I mentioned, it has a toolbar, a recycler view, and an optional footer. We've wired it up with Epoxy so that it automatically is going to call this build models method. If you're used to React, this is kind of like the render function. You return a list of components. It will then get reconciled on a background thread, and only the changes will get rendered on screen. It looks kind of like magic, so let's break it down. This is the code that generates it. Here we have a class header. It extends frame layout, and it's pretty simple. It extends a layout. It sets a property that's a text view. We're going to call it title view. And then there's a function called setTitle. We'll just go ahead here and annotate the header with model view. This is part of Epoxy, and it's automatically going to generate a recycler view view holder layout, all the item view type, and everything like that, and then generate what's called an Epoxy model and with a Kotlin DSL wrapper, which is where the header on the left comes from. We'll then go ahead and annotate setTitle with text prop. It will then generate properties on the Epoxy model that it can use to automatically diff the data in the background. Text prop is also a little bit special as well because it's going to generate overloads so you can do things like set Android string resources instead of raw strings. So this is what the code looks like with just Epoxy. We use it on pretty much 100% of our screens and have been for a couple years now. It's also been quite effective for us. But let's add Mavericks. This is what it looks like with Mavericks. We'll start at the top. First, we have a state class. This is an immutable Kotlin data class that extends Maverick's state. It should contain all the information you need to render the screen. You see we have a title, it's a string, and we're going to give it a default value of hello world so that it looks like the screen we just saw. We'll then generate a view model. This extends the Android architecture components view models so we can leverage all the work that they're doing. And if you want to build things on top of view models, you don't have to stray too far from the default path in order to use Mavericks. You'll notice that it's generic on the state class we created because it owns the state. It's the only thing that can modify the state, and from the outside, all you can do is observe state changes. And then we need to give it initial state because there always needs to be some form of state inside of the view model. We then have a getExcited function that'll call setState. This is very similar to React setState if you've ever used React. You pass it a reducer. In a reducer, it gives you the current state and you return the new state. We've used Kotlin syntax here so that the this inside of the block is the current state. Copy is the copy function from a Kotlin data class, and it's going to return a new state with title updated with an exclamation mark appended. We then have the same fragment we saw before, and we need to get an instance of our view model. So the architecture components come with a view model providers thing, method you call it, and onCreate, something like that. It will give you a new instance if you're coming to the screen for the first time, but it'll give you an existing instance if you go through a configuration change or come back from the backstack. Now we've wrapped this in a Kotlin delegate, so all you have to do is call fragment view model. If you call activity view model, it'll give you the same instance across any fragment in your activity, so it's trivial to share state between screens in an activity this way. We then basically have the same build models function, except now we've wrapped it in with state, and we get the state so we can render state.title instead of just hello world. The delegate we saw is automatically going to subscribe to any changes in the state in a lifecycle aware way and call this build models method anytime it changes. So we don't have to write any more wiring code. We don't have to subscribe and unsubscribe from anything. We don't have to know anything at all about the Android lifecycle. Mavericks handles it all for you. But let's make it a little bit more complicated, because inevitably you're going to have to do like a network request or a database request or some sort of asynchronous action. Let's just go ahead and go back to our state and change the string to async string. This is a Kotlin sealed class, and it has 4 types: uninitialized, loading, success, and fail. It's generic on the type that you want, and the fail will also have the error inside of it. We'll just set it to uninitialized right now. Now, in our getExcited function, instead of just adding an exclamation mark, let's actually fetch the title. So we're going to do title request.create. This is going to be an observable of string, right? So this could be your network request or anything that you want, but it's just observable of string. Execute is an extension function on observable inside of a Mavericks view model. It's going to take that observable stream and map it to an async stream and then call your reducer anytime there's any new data. It's also going to start with loading so that you get full loading states, success states, and failure states with just one line of code. Going down to the build models function, you'll see instead of just calling state.title, we're now going to invoke state.title. Now, invoking state.title is possible because in Kotlin, we can override the invoke operator. And when we call it, it's going to return the value if it's successful and null otherwise. So here, if it's not successful, it's going to return null, so we'll show loading and return. It would be really trivial to add failure states here because you could check if it's an instance of fail and you can pull the failure off of it if you want. But here, for simplicity, we have full support for loading states. Kotlin is then going to smart cast that title from nullable to non-null, and we're going to set a header with a title. And this is what it looks like. To summarize, you might have noticed that in none of these examples was there a single Android lifecycle. Everything in Mavericks is completely lifecycle aware. It uses the new lifecycle observers and lifecycle owners so that it does everything for you. You don't have to manually manage subscription and composite disposables. And everything that you saw actually also runs off the main thread. Build models is called off the main thread. It does a diffing off the main thread. Your set state is called off the main thread. Because Mavericks was built from the ground up to be completely thread safe and automatically backgrounded by default. That being said, you can synchronize everything for tests, but you get everything for free. None of this, you don't have to teach everyone how subscribe on and observe on works. You don't have to manage your subscription and make sure that it all works with the lifecycle. Mavericks does all of that for you. Mavericks is also Kotlin first and Kotlin only. The primary goal of Mavericks is to make it easier to build products. Kotlin has a lot of language features that lets us build really amazing APIs, and we wanted to fully leverage them. So honestly, we didn't even try to do it in Java. Kotlin first, Kotlin only. It's also just a fragment, and it uses architecture components. So even though it's a framework and you can use it to do things like share state, you can even use it for an individual screen. A lot of the adoption we've seen at Airbnb is someone who just wants to use it, and they just use it for a single screen inside of an existing flow. It works just like anything else, and if you use it like a fragment, it's just a fragment. You don't have to bring anything else. It doesn't interact with anything outside of itself. It even has a lot of Android things built into it. So things like process restoration and save instance state are all handled, and there are patterns and tools built into Mavericks to handle that, so that if Android kills the process in the background and you come back, it can actually restore your view models and your view model state in a new process based on tools that are built into Mavericks. Now, this is a pretty simple screen, but we're actually rebuilding the most complex screens we have in the entire app with Mavericks. We have screens with swipers and view pagers and maps and videos and batching and prefetching and everything under the sun. And they're all moving to Mavericks because it even makes their job easier. And one of the features we translated, it actually went from 2,400 lines of code to just 600. And we re-implemented the to-do blueprint app that's in the Google samples repo. We followed it 100% feature complete to its specification, and it has half as many lines of code as the next shortest one. Really only about 750 versus 1,500. And the reason I decided to add this at the end of my talk today is because we've been working really hard over the last month to open source it, and it's available today. If you go to our repo right now, we just pushed it live, or will in like 20 minutes, right after this talk. But we have a blog post, we have docs on the repo. It should be on Maven as of now, as soon as it propagates. but we really want to work with you guys because this has been a really effective tool for us. It's enabling us to work faster, and we want to work with all of you to make it even better. So this is our experience with React Native, cross-platform, and we even started to talk about an MVVM framework, and I'm really excited to share it with you. I think there's a break after this, so you can stick around. I'll stick around here. If you have any questions, you can always reach me on Twitter. My handle is GPO8, but I'd love to work with you all on this, and I'm really, really excited. So thank you for coming today.